right, here's quick time.
Look at Lindsay, like,
Um,
she's so jealous.
I'm gonna,
Yeah, she's like,
let's see, Alex, will you read me number 1?
yeah, sure. First question, y equals x squared minus 6x divided by x minus 1.
All right, my first thought is, I'm just gonna work them. I'm just gonna go, this is how I would work it, okay? My first thought is there's a vertical asymptote at x equals 1, but I'm gonna double check and make sure it doesn't make the top 0. Don't call it a vertical asymptote if it makes them both 0, okay? The top, I believe, is -5, if I fill in 1. And so it is indeed a vertical asymptote. To get full credit, don't just say 1, you've gotta say x equals 1 for verticals, okay? So, I'll come over here and see what color we can see on these beautiful girls. Now, one thing I got to Mia's and hers was just darker. I'm sorry, I just sort of, by the time y'all did that also over here. You don't want to give, I think I mentioned this before, I see graphs sometimes, like for instance, I always have dramatic examples, but when I had cancer, or when I take my kids to the pediatrician or whatever, the doctors are always, sometimes they have an actual, like, Apple TV in the room, or they'll have a laptop and turn it around, and they're showing me a graph. It better have numbers on it, and it better be drawn to scale, or it's not going to mean anything to either one of us. I think I kind of used the money comparison the other day. If I had $1,000 that turned into $1 million, I would so desperately want that graph to be drawn to scale. Can you imagine as a professional giving somebody a graph of what has happened to them medically, financially, architecturally, or whatever it is that you're talking to them about, which, by the way, we talked about the other day, your parents are probably looking at graphs right now. They're not thinking math because it's part of their job most likely, but they're probably pulling up a graph of something. Can you imagine if it wasn't marked off or drawn to scale? You can't even be as lackadaisical as this, where you go, oh, this is 1,000 and this is 1,000,000. No, it's not. I mean, not if this is 1,000, right? I mean, you really want to make an impact with your graph, and that's why you're doing it. And so you would need to see a big discrepancy between those two. Granted, I don't want to count by 1,000s up to 1,000,000 unless it's my money. Then I'd probably be really excited about it. Go get a poster board and go 1, 2, 3, 4. Okay. But I could rescale it, right? Okay. So that's something that's going to come up for us. All right. So you've got to mark, but just what I'm doing is what you need to do. Okay. Sometimes I've started drawing it and the numbers are big outside the -10 to 10 viewing window. And sometimes I have to change my mind and start a new graph. That's not the end of the world. I don't require that you even write in pencil, but I think most of you do by habit. You can just cross it out and draw a better one when you get ready. I draw as I find. That's my recommendation. All right, so now I know I have a vertical asymptote at x equals 1. Tell me if you're counting, if you just do this, I just assume you're counting by ones.
Yeah.
Okay? If you're counting by 2s or 5s or something, just label a couple so that I know 2, 4, okay? X equals 1 is my vertical asymptote. Now if you have your calculator, that would be dotted. If you have your calculator with you today, there's actually a way to draw it down up here. Whoa. Okay. Go ahead and in parentheses type this into your calculator. Yeah. Isn't that cool? Okay. So, if you'll go in and type that in with parentheses. Alright, so far I've got my horizontal asymptote. And, I'm sorry, vertical asymptote. It does not have a horizontal asymptote because it's top heavy. If it's bigger on the top, common sense tells me it's going to go off somehow to infinity. And those are those end behavior models that I talked about, okay? This one is an extra special end behavior model because how much bigger is the top than the bottom? 1. So how do you find your slant asymptote if the top's 1 higher than the bottom? Long division. All right, so let's go to a new slide to do long division and we'll come back. All right, you've got to put in your placeholders. And so you have x squared minus 6x plus 0. Was it x minus 1?
Yes.
Alright, what goes into this? X. I'm gonna do it really fast, so just stop me if you're lost, because today's the day to make sure you're found. I'm gonna subtract, cancel, negative 5x plus 0. And so then I'm gonna need a what? Negative 5. And you can finish it if you want to. It does tell you something. I'm going to finish it right now. You may wonder why I am, because can you already see that it's y equals mx plus b? So I already know my slant asymptote, but it may make an impact in minutes, whether you have a remainder or not. And I've explained that a bit, but I think today I'm just going to start cranking out problems. Negative 5x plus 5. It doesn't go in what I would call evenly, and I have a remainder. You don't have to even go that far yourself. Once you get this far, you have your slant asymptote. So my slant asymptote is y equals x minus 5. Okay? Now, one thing, hang on just a second because I don't forget your question. One thing I don't know if I got to show you yet is you can also check and see if it crosses that asymptote. You can cross a slant or a horizontal asymptote. You just have to stay close to it. Nobody said, like a taxi driver, that you couldn't like cross into a different lane and then follow the asymptotes. Okay, so you'll hear some teachers and students say, you can't touch an asymptote. That is so not true. Okay, you can't touch a vertical asymptote, but the other ones are just lines that you're supposed to follow off to infinity. Up close and personal, it may look like I'm only looking at the girl that wore a pink shirt and sneakers to mass. But if I pull back and look at the big picture, I see the uniform. Do y'all see what I mean?
Mm-hmm.
All right, Dakota, do you remember your question?
Yes. So this might be a stupid question, but why would you not subtract 5x plus 5 from negative 5x plus 0?
Where's my long division? Here it is. All right, I hope I did. Maybe in my hurry I didn't. All right, to make that match, I need a negative 5. So I put a negative 5 right here, Dakota, which gave me negative 5x plus 5. Okay? Like if I multiply negative 5 times that, I get negative 5x plus
Negative 5x. Wait. Oh, okay. I
Because you
see.
want them to match.
Yeah, I got positive 5x. That's why I was confused.
You want them to match.
Yeah.
So then when you subtract like this, they actually
Okay.
cancel out. Okay?
Yes.
Wait, so then is the slant asymptote the remainder?
The slant asymptote is right there, y equals x minus 5.
Okay.
I don't know if you realize what you've done. I don't think, I didn't even told the honors class this yet. If Anya has 2,400,000 and, let's see, let me change it again. If she has 2,010,420 and you have $998,799. First of all, Anya has a lot more money than you. How much more?
Oh, 1 million.
Ratio wise. She has twice as much more money as you. Then you do a quick division in your head without worrying about the remainder. Do y'all see what I mean? That's what that slant asymptote is about. You're doing a quick division just to go, oh, this is what happens in the long run. I don't know if that helps. So at the top, you're finding what happens in the long run, and I didn't get it exactly, and most of the time that's not going to be exact. In fact, let me go there, that you asked the question. If I didn't have a remainder, if my remainder was 0, it will be an exact division. And so not only will it follow the asymptote, it will be right on the asymptote. Okay, but you see the sense here of what's happening when I pull this up? Okay.
And when the exponent is not 1 above, there cannot be a slant asymptote.
Cannot be a slant, and then you just have the knowledge of the shape.
Okay.
Okay? And you don't have to write anything down, you just have a knowledge of the shape.
Okay.
Okay,
And how?
let me keep doing problems, because I'll get to it. All right, so my slant asymptote is y equals x minus 5, so I'll go to this cute little thing. And the y-intercept's negative 5, and so anyway, I take for granted you signed up for pre-cal so you can find your line, y equals x minus 5, however you do it, okay? Now, I call these pockets, like, it can't be 1, right? That means by default, there's gonna be something, whether you see it on your screen or not. Y'all want to get your calculator out if you brought it today. It can be very dangerous for you to only trust your screen, okay? You've got to really trust yourself and table more than your graphing screen. Life doesn't exist in a negative 10 to 10 view anymore. Here's what happens, is it's gonna sit here or here on that side of 1. You see that little pocket it can slide into, or this pocket? And over here, do you see this funny shape and that funny shape? It can't be both because then it wouldn't be a function. Y'all see what I mean? If there's like a funny thing here and a funny thing here, it wouldn't pass the vertical line test. So I'm gonna find a few points and then it'll slide into this pocket or it'll slide into that pocket. On the other side of where it's undefined, same thing, okay? So I think it doesn't have a hole, right? No hole. And no horizontal asymptote. And I haven't told you how to check to see if it crosses the asymptote, but I'll do that in a little while, okay? So now we're ready to graph it. And so if you'll go, if those of you that have it in your calculator, you may want to help me find some points. Go to table. I can do 0, I get 0, I believe.
Yeah.
Okay, what's negative? Just find a few around where your graph is sitting, okay? In case you wondered, when I first started doing this a couple of days with y'all, a few days ago, I said I'm just picking these numbers at random and I was in a hurry to get some done because we probably wasted a lot of time with me talking about other stuff. You want to, your asymptote's at 1, so you want to find out what's going on there. The beauty of table is if you get confused, you can just chill and go, I want to know what's happening at 10. It may not apply to you, but it's such a quick 1-second check. So now, do you have -3, Brent?
I have -1.
-1's great with me.
-3.5.
All right, 1, 2, 3.5. So what's happening is this. It's sitting in there like that. Okay, so it's just, you can find some more points, but that's the beauty of asymptotes, okay? I don't need much. In fact, some of them, when I don't have asymptotes, I'm a little unsettled because I'm like, now I wish I had some guidelines. Find 2 or 3 points in there and just sit it in, okay? Now I need to check on the other side of 1, okay? Do you have some points on you?
Yeah.
I
I have
2?
2 at -8.
Okay, 1, 2,
And
3,
then
6, 7, 8. All right,
4 and 5 are kind of weird.
okay, that's fine.
But 5 is at -1.25 and then 6 is at 0.
Okay, so this one is coming up like this and then following it off like that. Okay, I think your graphing calculator gave you a pretty good picture of that, actually. But don't trust it, okay? Make sure you know what you're doing. The last thing I ever do is hit graph. It's not the first thing I do, it's the last thing I do. Okay, I'm guessing it's your window, but I'm not sure. To get it back to normal, put zoom 6. Zoom and it says standard. Zoom, there's a zoom on there somewhere. Zoom. You okay now? All right, but now you don't have the right graph. Did you type in your equations? Wow, your screen's so.
It's so dark, I don't know what's wrong.
This is a little bit better. You have got to put the bottom in parentheses. All that's doing right now, Alina, is dividing by x. It's not dividing by x minus 1. Okay. One thing that Alina and I were talking about is your calculator doesn't have a, do you have deodorant if anybody needs some?
She's
The calculator doesn't have a brain. Out there, outside of this room, you may hear like people griping that like Miss Lazari lets her kids use a calculator, Mr. Hill doesn't in honors pre-cal. The calculator doesn't have a brain. It's not gonna help my students do better. It's just the skills that I'm trying to teach them for AP Calculus, because half of AP Calculus test is gonna be, you better have some calculator skills that you don't learn in regular classes, okay? And I'll be teaching them to you also. But I think you all know that you could have a calculator in your hand and easily fail a math test if you don't understand what you're doing, okay? So, you are the one with the brain. That's why we've got to put this bottom in parentheses. Your calculator, at first when people get them, they're scared of them. They think the calculator's in charge of you. It does not have a brain. You're the one in charge. You are driving the calculator. And if you don't put the bottom in parentheses and the top, it won't know what to divide. It'll divide what you tell it to. Without parentheses, it won't be dividing what you want it to, okay? Anya?
When we're on our test, when we're expected to graph something, we can just plot, like, we can look.
You can do this.
Like, plot 3 points, and then you can just, like, kind of follow the graph, so it doesn't
Yeah.
matter if, like, it's like a little line off as long as you have those, like, 3
It won't
points.
be, I just gave my, honors test.
Mhm.
And it's amazing once people get as much as we'll get done today, how much they look alike. Like if I hold up yours and Dakota's and Mia's, you know, then and Ava's, I remember hers, even Ava, did I call that right?
Yes.
It messes with my mind the way it's spelled. And I'm sorry, probably other people's too, but, when people are doing it right, that's the beauty of asymptotes, is I really can't even tell how many points someone found. Don't overdo it, go on to another problem.
Okay.
But you know what? You know enough now to, even if you found other points, look what would happen. It would
would
just start
just, yeah.
landing what you already know on your pattern, okay? It's sort of like when you color by number, if you've done that.
Yeah.
A lot of times I would outline it in red, and then of course I'm still coloring all the red inside the R's wherever it said red, but nothing's gonna change in there. I'm coloring that part red. Bryn?
So you'll want us to graph a few points, right?
Oh, please, yes. Because things, you're still investigating. Those points, Bryn, are gonna tell me where this thing falls.
Yeah.
Let me go in and show you how to check for cross, okay? You will see some graph, I hope today, and if you don't, I won't let it be on the test, I'll just show you after the test. There are times, let me make up one, where one crosses the, asymptote. It does what I call it's really misbehaving. It's like we told it to stay with us and it's trying to get away. But from the big picture, everybody else is following the rules, okay? You might be the sibling that is kind of the goody-goody like I was, and my sister was always in trouble, and I just kind of looked at her sometimes when my parents are disciplining her and the teachers are mad at her at whatever. It was just her personality. She's awesome today. She's just fantastic. She's at the beach with her whole family right now, so she has 3 boys. But so that doesn't mean that you or your sibling's not going to grow up fine. It just means that she's very witty, and it's a good trait. It's just harder to raise, I think. But my point is, I just sit there and look at her, look at my friends in class sometimes class clowns are fun, really fun, and teachers like them. But then there's the overboard where you're just going, don't do that anymore. I just kind of wanted to go down to my sister's room and go, why don't you just do what they tell you to? Like, that's not very hard. So, that's what's happening here, is you're kind of looking at a few parts of the graph going, why don't you just do what we tell you to, okay? But the rest of the people are gonna be sort of following the rules. We're not always following the rules, but we're gonna stay kind of close if we don't want to get in trouble. If you don't care, then you can just wander off away from the graph, okay? All right, so here's one. Let me change something here. Boy, it's hot in here, and then it gets too cold. We can't be happy. I think this is one. I'm not sure. I'm not going to just stress over making one up, but
Wait, this wasn't one on our homework,
No.
right? Okay.
all right, here, do y'all see the top is one higher than the bottom?
Yeah.
So it will have a slant asymptote. And I'm gonna find it real quickly. You don't have to work with me, you're just gonna watch. So we can hurry up and move on. All right, so I'm gonna go to a new slide and x cubed minus 9 and x squared plus 3. This is a great example, by the way. So,
Are we
help me
doing?
remember, no, please don't write. Please just watch me, okay? X cubed minus 9, so 0x squared plus 0x minus 9. And I think it was divided by x squared plus 3.
Yes.
So I need x squared plus 0x plus 3. Do y'all see how I had placeholders in the dividend and the divisor? Alright, so I'm going to put in x, and that gives me x cubed minus 0x squared plus 3x. Subtract, subtract, subtract. And I get 0x squared minus 3x. You can't make x squared go into a 3x. Like, basically you multiply by 0, right?
So that's your remainder?
So,
Or
yeah,
x-
all of this, I'm done. So y equals x is my slant asymptote. We will see this graph follow it, okay? So y equals x is my slant asymptote. And so let me pull up my calculator again. All right, and now let's put in y equals x. Thanks. Let's see. All right, so it sure does look like it's following y equals x. But we have a few disobedient people in there. There's the guideline that you're supposed to be following. But did you see that can you barely see it started, the blue line was above the red line? And then this person go, I'm gonna run away. But what happens? They get come back over here. Do y'all see what I mean? So don't worry, it can cross the asymptote and it can kind of go far away from it. But in the end, it's gonna get pulled back to the rules.
So are we gonna have something like that in our
Only if I really do more, okay? Okay, so let's just see what happens. Now, on this problem, now that I've made up a new one, let me think to myself how, I don't know that I would give you one with all this x cubed in it, so let's move on. Let's just see what happens. All right, so let's go to number 2. Alina, will you read me number 2?
Yes. Y equals x minus 6 divided by x minus 1.
Y equals x minus 6 divided by x minus 1. All right, pretty easy vertical asymptote, only at x equals 1. There's no hole in the graph because I didn't get a 0 over 0. There is a horizontal asymptote, not a slant. There's a horizontal asymptote at y equals what?
1.
1, good, Anya. All right, watch my hand, because you won't see this if you watch the video. But if I cover that up, that's like me going, I've got $1 million and you take $6 away from me. If I really only had $1 million, I might be a little upset, because I don't know if legit I could say I'm a millionaire. But most likely I'm not real upset, because I'm still a what? Millionaire. Do y'all see what I mean? So I don't think anybody's would be that picky if I'm out $6. Do y'all see what I mean? Those fade in insignificance, and this has all the power, okay? That's what the notes we wrote the other day. If the highest powers are the same, you just look at the coefficients, okay? So this has a horizontal asymptote of y equals 1. And that side of the board is not oriented as usual. All right, so I have a horizontal asymptote of y equals 1. As of right now, unless I decide otherwise, I'm just going to count by ones. So you label your graph. I won't give you full credit if the graph's not marked off. Y equals 1 is your horizontal asymptote, and x equals 1 is your vertical asymptote. Still kind of missed
Y
one.
equals 1 is your vertical asymptote because the top are equal.
Yeah, and your coefficients are both just 1.
Got it, thanks.
Okay? If I had this, if I had y is equal to 4x cubed, blah, 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 over x cubed, blah, 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 blah. I don't care what's back there. It fades in insignificance when I'm talking about leveling off. It'll level off at 4. Y equals 4 will automatically be your horizontal asymptote. Okay? If the powers are the same, just reduce to the coefficients. All right, now, On this one, let me go in and show you how to check for cross, because there's a lot of room to write up here. We're gonna find some points in a minute, which we'll do in just a second. It's really nice to know if your graph's gonna go whew when they go off somewhere else, because again, your calculator screen, who knows what it's gonna show you, because it's only made up of what we call pixels. That's a little square that it can light up or turn off. It's just binary. It's all for own, all for own, all for own. And they're better today than they were 10 years ago. I mean, I would actually have students that didn't have any idea what they were doing, and they would copy off their screen, just something like this, which is not at all what was happening. There was an asymptote in there, but the graph's having a hard time showing us. They are better today, but it can still be very somewhat deceiving. So you stay with me. Okay, so to check for cross, what I mean is once I start drawing this, I want to know if it's going to cross what?
The y-axis.
No,
The asymptote.
the asymptote. I want to know if it's going to cross y equals 1. It can't cross x equals 1. That's where it's completely undefined, okay? But it'd be nice to know ahead of time if it crosses. A lot of graphs don't cross, but it can. I've seen a lot of graphs that do. Common sense. When I start graphing this, I want to know if it's ever going to hit this. Do y'all see the common sense behind them? I'm about to draw some points, and I want to know if any of them ever land when y is 1. Do y'all see those are both y equals? So I'm just use substitution. I'm just going to do common sense. I'm going to go, hey graph, x minus 6 over x minus 1, are you ever going to hit 1?
Oh,
You
so
see
you find
how
that in the
common-
table.
No? Do you see how common sense that is though? I just want to go, are you going to be you? Is this going to ever hit 1? All right, let's see what happens here. So I'm checking for cross. And this gives me x minus 6 equals x minus 1. What happens to my x's?
They
Cancel. And last I checked, negative 6 did not equal negative 1. So it's trying to say, no, I'm not going to cross. Okay, if you get nonsense, it's going to say, no, I'm not going to cross. If it's going to cross, your x's won't cancel, and it'll say x equals 5. 5's the bad person. I'm going to hit the asymptote, and I'm going to run away for a while. Or the good person. My sister's a lot better person than I am, probably because she was so creative, okay? But, do y'all see what I mean? Sometimes I think it's a good person to cross the line and to get away from the asymptote. That just gave me goosebumps. Do y'all know the step out of line phrase?
No.
You'll have to look it up. If somebody, I don't follow politics because I don't really trust any of them, so you know, I'm sure that's neither beside the point, but we won't talk politics in here because I don't know anything about it, so I can't talk about it. And I don't trust the media either, so I can't tell what's, and I can get my best friend here and my best friend here and they like, don't agree, I'm just like, I'm just gonna run and teach math. But, anyway, I overheard, y'all can ask Miss Cece about it. She was telling me, there's some famous person that I probably should know, there's probably some female, candidate for president. I really don't do politics. but
Was it Warren?
No, it wasn't. I know of her, so I at least know that. Anyway, I don't think they are, but whatever. I'm gonna tell the story wrong, but it's a cool story. So look up the right story. I'm just gonna kind of get it right. There's a woman whose like great grandparents were maybe Jewish or in a
Oh,
country.
you're thinking of Alex Bornstein from the Emmys.
Can you? Oh, okay. Can you tell
She
the story?
was in Marvelous Miss Maisel, yeah. So like her grandma was Jewish during World War II, and she was like
Thank
in
you.
a line to like be shot into a pig, because that's how they used to do like executions.
So they were gonna go.
Yeah, during the Holocaust. And so she was like, the grandma asked like the guard, he was like, if I step out of line, are you gonna shoot me? And he was like, no, I don't have the heart to do that. So she stepped out of line, and then she's like, so now I'm here and all my children are here.
And then she ends, I think, with "Lady, step out of line."
Yeah.
I think. I don't know. It was really cool. I mean, I think in a lot of situations she would have gotten shot, but
Yeah.
anyway, that has a little bit to do with asymptote. My point is, I'm not saying don't ever step out of line, don't ever cross the line. I'm not saying that. I know my examples get kind of crazy sometimes, but in any event, this one's not. This one's gonna follow the rules, okay? Whether you know, so it's gonna go, okay, I'm not gonna cross, and so when I'm talking about this pocket or this pocket, it's only gonna be in one of those two in this part of the graph. It's not gonna cross over into the other one. So now I can very comfortably graph it by finding points, which I'm gonna do real quickly so we can move on. But to check for cross, you always just set one of your y equals equal to, you just set them equal to each other.
The numerator
Either
and
the hard,
denominator?
no, you set, what you're doing, Brand, is you're about to graph this,
Yes,
and you wanna know if it ever hits this.
yes.
So you set your equation equal to what you're wondering if it will cross.
So you set the equation
Wait, sorry.
equal to the vertical asymptote.
Or, no, it will never cross the vertical
horizontal.
asymptote.
Horizontal,
excuse me.
It can also cross the slant, I just showed you one.
Yeah.
Okay, so the vertical asymptote is x equals, so that's out of the question anyway. The other ones will both be y equals. Okay, so you just are using old-fashioned substitution. Do you know what I mean by that? If y equals this and y equals that, you can set them equal to each other or substitute in for y. Right now, I'm just doing this. There's my horizontal asymptote, and I'm just putting it in. Get it in a minute. I'm just putting it in right here. Do you see how it said y equals 1? And I'm putting y equals 1. Y equals 1. I want to know logically if this is ever going to hit that.
Yeah.
It just makes sense. Okay? It's just like, are you going to, I was almost going to say Neo's or Dina DeLuca, but we can't say that anymore. Like, are you going to go to Starbucks? I mean, are you going to go to one? Are you going to hit it or not hit it? Okay?
I have a question, I don't know
Okay.
if this is, well, this is just for one technically, but can't you already know that the graph isn't going to hit one because that's the vertical asymptote?
We're talking about the horizontal asymptote of y equals
That's what I
1.
was-
Oh,
It cannot cross the vertical asymptote because that's where the graph is undefined. Horizontal asymptotes are not about if the graph exists or not. Horizontal
Oh,
asymptotes
it's
is just
where it's
follow
gonna-
me.
okay,
And you can land right on it if you want to, okay?
Oh, okay, that makes sense.
Okay? You're not gonna ever cross a vertical
wait, so I'm
asymptote.
confused on what this question was solving for.
Okay, I hadn't graphed it yet, but I wanna know ahead of time, when I start to find my points, I don't wanna be confused by stuff like this and go, whoa, what's happening? I may already know that it's gonna cross the asymptote.
Yeah.
So I wanna know ahead of time if that's gonna happen, because
Oh.
then my points make great sense to me. If it does, if I don't understand cross, I'm gonna go, whoa, what's happening? See, the graph is following it all, okay?
So you're gonna set it
There's
equal
no
to-
rule that you can't, it's sort of like if I say cut along the dotted line, follow this pattern, and you thought you couldn't actually cut on the dotted line. You're just gonna cut close to the dotted line, and if you cut on the dotted line, I'm okay with it. If you cross over it and you're on the other side of the dot, do you see what I mean? So I wanna know if, it's very logical, so the logic's probably not trying to know for a lot of you yet. I'm about to find points here.
Okay.
And I wanna know if any of the y's are ever gonna actually be 1. I wanna know if any of my y values are ever gonna actually hit that graph.
Oh, okay, so that's when
So-
you set it for 1 and then you try and
Yeah,
solve that?
and they're
Then-
both equal to y. Do you remember in algebra 2 where you had like y equals x minus 7 and y equals x squared
And then
plus
you had to,
4 and
like-
you set them equal to each other to see if they're gonna cross.
But since we got -6 equals negative.
That's
negative
nonsense.
It means it
Not
doesn't.
gonna cross. And so I know, so now I'm comfortable.
So can you plug any number in for that?
So I'm about to finish it. This can be, after Dakota's and Bryn's questions, can be one of those times that I gotta just go, okay? Dakota?
So you can't just find, like, you can't just graph your points that you find from the table and then like graph it on your calculator to see where they do. We shouldn't trust that to see if it crosses or not.
You just may not see it. I mean, I've seen so many things happen. I just am so familiar with the graphing calculator. You might not see it, or it might be extremely confusing to you if you ahead of time don't know your math. So in my experience with my students, I would rather you give something to really hold on to. You'll know before you ever hit graph. I'm not saying you couldn't figure it out in a different way, but we want you to finish your test and blah, 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 blah. Brent?
So we're never gonna be setting it equal to a vertical asymptote,
Don't ever.
but
It's point, it doesn't even make any sense.
yeah, so but will there ever
Wait,
be?
time out, that's like the third time someone's asked that, so it's a legit question. My vertical asymptote is x equals 1. I wouldn't fill that in for y, then what would I fill that in for?
X.
1 minus 1 gives you what on the bottom? Game over. Do you see that's not ever gonna happen, cause that's why you put that there.
Yeah.
Okay, the other one's just a guideline. Go ahead.
So would there ever be a situation where we're setting it equal to a slant asymptote?
Yes.
Okay.
Yes, because they're both y equals.
Yes.
You can touch a slant or a horizontal or any of those other things. You just can't touch a vertical.
Got it. So we will be setting it to any asymptote other than vertical.
Let me get some problems done.
Okay.
Okay, so now I'm gonna fill in some points real quickly, knowing that it doesn't cross, okay?
Yeah.
If I fill in 0, I get 6. 1, 2, 3, 4, 5, 6. And if I fill in -3, I get, let's see, if I fill in -4.
2.25.
Okay, 2.25?
Yes.
Alright, so this one's gonna come down like this and follow that pink asymptote off. And this one, if you fill in 3, or if I fill in 6, I get 0.
Mm-hmm.
And then I guess if I fill in 2, I get
-4.
-4. Thank you, Brian. And so it's going like this. And do you see how comfortably I drew that? I didn't need but a couple of points here and there, because then I knew once I found a point, it was gonna be in that pocket. If a point was up here and it doesn't cross, it's gotta sit in that pocket. Okay, let's go on to number 3. Is that what we're on?
Yeah.
Okay, Brian, you wanna read me number 3?
Number 3 is y equals 3x minus 2 over x squared minus 1.
-1. Alright, hopefully y'all know that this factors into x plus 1, x minus 1. Is that okay?
No.
That's called the difference of squares. X plus
Why does
1.
it go into that?
Would that also be multiple?
Oh,
Just
you
the
can't
bottom,
really
not the
see
top.
that, I'm sorry.
Could you have multiple vertical asymptotes?
Yes,
So is that one like example of two?
yes, in fact, later in the year, you'll have an infinite number of vertical asymptotes. It'll just go zoom, 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 zoom forever, okay? So yes.
Oh, yeah, for the vertical asymptote.
Yeah, the most we'll have right now is 2, okay? But it could be undefined anywhere that makes the bottom 0. So if you have a bunch of stuff down there, you've gotta worry about it.
Yeah.
So, this is 3x minus 2, and the bottom factors into x plus 1, x minus 1. Why does that little thing factor into that difference of squares? If you multiply that, you get x squared, and then what happens to your middle term that you usually have?
It disappears.
It cancels out. So that gives you x squared minus 1. So what is x squared minus 9? X plus 3, x minus 3. It's the easiest factoring that you get, okay? Because it doesn't have a middle term to finagle and worry about. When you have x squared plus 5x minus something, then you've got to get the 5 in the middle, okay? That's called difference of squares. So it appears for a moment that my vertical asymptotes, it looks like I have 2 at x equals -1 and at x equals 1. Then I verify if it makes the top 0, I check. Neither one of those make the top 0, do they?
No.
So this does not have a hole in it, okay? It has a horizontal asymptote because it's what I call bottom heavy. If a fraction's heavy on the bottom, it's gonna get what and what and what?
0, 0.
Smaller and smaller and smaller and go closer to 0. So my horizontal asymptote is y equals 0. So let's get this graph started.
And there's no slant. Because
Oh,
it's
you
not
can't have
x
both.
cubed.
I mean, it can't do this and this at the same time.
Yeah.
You see what I mean? So that's a safety net. You shouldn't.
You can't have slant and or
You
no.
can't. It's totally impossible. If I say you're gonna level off, then I don't know how you can slant off. Does that make sense, Anya?
Yes.
All right. So I'm gonna put my asymptotes in 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3. Sorry, this isn't very oriented, so my marks don't look as evenly as I'm actually putting my finger up there, but just pretend. X equals 1. X equals -1. Which that's not drawn as well as I would require you to, but it's not doing what I asked it to. And y equals 0. Alright, now I have no matter what your calculator says, there's a piece of the graph here, there's a piece of the graph here, and there's a piece of the graph here. It's got 3 pieces, okay? Your calculator might just go show you a piece over here. That just means you're not seeing what you should see, and you should go to table and ask it some questions. Because common sense, if it doesn't exist at -1 and 1, by default, it must exist everywhere else, okay? If I said, I'll have to make up fake names on the, 'cause I don't wanna hurt anybody's feelings. Let's see. If I said, okay, we'll do this, we'll hurt the faculty's feelings, I think they can stand it. If I said, I got a great story to tell y'all, why don't y'all go get everybody except for Dr. Dighton and Dr. Spicer. They seem like they can stand the joke, okay? So who are you gonna get? Everybody but those two. This is like everybody gets to play except for one and -1. So I need to see what everybody's doing. Y'all see what I mean? You're just saying these two can't be there, everybody else is. If you have it in your calculator, don't do it yet if you don't, because I want you to see what I'm gonna do next. This looks complicated, so I wanna check and see if it crosses. If what crosses? I wanna see if my graph crosses what? 0. Who said that? Nazareth, good. Alright, Nazareth, and I see that these are both equal to what? Y. So I'm gonna take out this Y, and what can I sub in for Y? 0. Okay, so you put those two together. So I get 0 equals 3x minus 2 over x squared minus 1. This is gonna be a good example. Alright, so cross multiply, 0 times that is 0, and I get 3x minus 2. I think I should keep on going, right? My x's didn't cancel out. So I'm gonna add 2 to the other side, and then divide by 3. So it's going, I'm crossing. Who's saying I'm crossing? Who stepped out and goes, I'm gonna hit the line? Who? Who says they're crossing? What's their name? Nope, who's crossing?
2/3?
2/3, what are they gonna do? They're gonna cross the asymptote, okay? Now, do you have it in your calculator yet? Type in 2/3.
And that's because you're setting it equal to each other and it.
Yes, yes, yes. I wanna see if it's gonna hit that, so set it equal to whatever that is, in this case it's 0. Did you put in 2/3?
My window is just on this one.
Don't worry about your window, you shouldn't be
It's
looking.
0.
Yeah, we already knew that, right? 2/3, you know how you're kinda used to going close to this asymptote? 2/3 is like, too bad, I'm gonna cross the asymptote, okay? Maybe on its way to misbehaving, alright? Now let's find some more points. Oh, by the way, why I like cross is now is my comfort zone. I know it's not gonna cross anywhere else, because if it was, it would tell me when I asked it. Are you gonna hit 0? Okay, I asked my equation, are you gonna cross my asymptote? Are you gonna hit 0? And the only number that popped up was 2/3. So all the other points I find is gonna sit in that pocket. Alright, somebody that has it typed in, put in -3, please, and tell me what you get.
You get -1.3.
So that settles it down here instead of up there. It could be either place. If it crosses, it could be in both. What was -3, -1 point something?
375.
And what's -1?
Error.
Oh, sorry, I just put that in the wrong place. I was thinking that was 0. -2.
-2.667.
So this sits right in here. And now, this is weird, okay? But that's the great thing about table. If you fill in 0, you get 2. And this graph, I think, is coming, sorry, I gotta kind of predict where the, okay. This graph is coming down like this and turning. It's extremely disobedient for a little while.
That's what
Okay.
I was asking you about.
Yeah, oh, you were the one I sent the picture to, I think. Yeah, so it was me, it was someone in here. And then over here, what happens if you fill in 2?
You get
1.3633.
1.3 repeating.
1.3 repeating, and so that one sits over here. Alright, now let's look at it on the calculator. And how do I expect you to know that? You've got the brain. Mia will tell you if you just look at it on the calculator and that's all you're going to look at, it's going to be confusing. But girls, I didn't even turn on my calculator yet. okay? All you've done is give me points. I haven't even looked at the graph, but I already know what it looks like. In that little in-between part right there, you have the wherewithal with your table to find lots and lots of points. Like for instance, let's do this before I go on. There's something going on between -1 and 1. I'm gonna tell you, sometimes you don't even see it on your screen. It's up at like 25. How are you gonna know that's there? Who are you gonna ask? Table, and it'll go up there. If you put in 0 into table, you get 2. If you put in 1 into table, you get undefined. But that's the beauty of table. Can't you then put in 0.5, 0.7, 0.9? You can find all sorts of points between -1 and 1. Okay, so I have parentheses are important, 3x minus 2. Oh, I don't know what I'm doing. Okay, I can touch it up here, I always forget that. Alright, y equals 3x minus 2 divided by x squared minus 1. And I don't need that because I don't have a slant, I have a horizontal. Alright, I'm going to go just to my standard viewing window. And it's a great graph. If it wasn't great, that's okay. I mean, but look how good we did. Should be able to grab that. See if I can do it here. Doesn't matter. I mean, I think you get the point.
This is right.
Look how good we did. Okay?
So if we
Wait, time out. Did y'all see it just went right through y equals 0 for a moment? But did the rest of the graph behave? If I look at it from an airplane, most everybody is gravitating towards 0, aren't they? Anya, look.
Yes.
Out here, okay? This is when I was coaching like 4th and 5th grade. There were a few girls doing that. They're like, I couldn't even hardly walk into Central Park, so I quit talking. I mean, coaching middle school. I just didn't, I'm like, why are you over there? Why are you over there? Why are you over there? And then there's these like girls that are just following me, but I'm worried about all of these people that are like, then I would go run around this, and they would go, but can I do jumping jacks? And I'm like, okay, so anyway, question.
So what you mean by when you plug in 0 and you get 2, does that mean that the y-intercept is 2?
That is the y-intercept.
Okay, cool.
Yeah, I'm not gonna ask you for the y-intercept, I don't think I have before, but if I do, you put in 0 and that's your y-intercept.
Okay, cool.
0 is just a good point to fill in if you can. Okay, Dakota?
For studying for the test, are there any like packets or worksheets or things online?
Let me do one more problem and I'll show you a great practice, okay? And I'll provide it to you. Let me look at, do you mind if I look at yours? Okay, so, 4 is probably great to do because it has a hole in it. So let's go, I'm gonna go through this fast, okay? So this is number 4. Elena, I already forgot what it said. Can you tell it?
X plus 1 over x squared minus 3x minus 4.
Okay. I'm looking for vertical asymptotes, therefore I'm gonna factor the bottom. And that gives me x times x, 4 times 1, minus and plus.
Yeah.
Okay, yeah, I think you'd already done tried 4 and 5 actually, or yeah, so you had done more. So I have a vertical asymptote, I think at x equals 4, and at x equals -1. Is that true?
No.
What should you check, Ava? The top. Okay, very good. So if we fill in -1, we get 0 over 0, don't we?
Yeah.
In fact, you can cancel this out. Let me rewrite it. X plus 1 over x minus 4 times x plus 1. This cancels, and really it's gonna look almost just like this, except for at one point. So to just what you can see, it'll look just like this. Okay? So this is, you do not write that by vertical asymptote. It is not a vertical asymptote. It's not that you ripped the sleeve off of my sweater. Okay? It's just a microscopic hole. So now, how do you find the hole? There's 2 ways to find the hole. One way is to take this -1 that you just canceled out and fill it into what's left over. I don't know what just happened to my screen. Fill it into what's left over. What do I mean by what's left over? I watch this, girls. try as I might, I can't fill -1 into that. I'll keep getting 0 over 0. Like again, I'm not getting any headway with that, okay? But this one's almost just like it. Can you fill -1 into this one?
Yes.
And you get -1/5. Okay, if I slam it in table real fast, keeping an eye on the time.
So is that just getting rid of the X on the top?
I'm not sure what that really means, so
Or you
I'm.
got rid of the X? Like it said, because when you factor.
It's getting rid of -1 is what it's doing. It's not really getting rid of an X on the top. It's getting rid of X plus 1. I don't care if it's on the top or bottom. I really got rid of it on both.
Yeah.
So I just threw -1 out the window. Act like it's not even here. Okay. X squared minus 3x. I keep forgetting I can do it up here. Minus 4. I'm not even gonna hit graph. I don't even really care. I'm gonna go to table. Do you see at 4, it's undefined. And at -1, it's undefined. Do y'all see that? Look what happens if I get closer to 4. 3.9, 9, something like that. Don't get carried away. It's at -100. That means it's going to negative infinity. But look what happens when I get closer to the other one, -1. -0.99. I can't fill in -1, it's undefined. But you see it's getting closer and closer to -0.2. Guess what -0.2 is? 2/10 or what?
1/5.
1/5. But I wouldn't care if you wrote your whole was at -1, -0.2. You can give me a decimal or a fraction, okay? So you can investigate it with table. You can go, well, the hole's there, but how close can you get to the hole? Infinitely close, right? With table. Most of y'all will factor and cancel and fill it into the leftover.
Wait,
So
I'm
let's-
just confused on why 1's still on the top. I thought we crossed it out when we crossed out both X plus 1, X plus 1.
Okay, this is what I'm working on now.
Yeah, I'm confused why there's a 1 on the top though still, because on that one, when you crossed
Oh,
out X plus 1.
Well, then what are you gonna do?
I don't know, that's what I was
I mean,
confused.
the X minus 4 is on the bottom, so what are you gonna do in this situation?
Oh, you just leave it there. on
Like
the
if you
bottom.
have
Okay.
3 over 9, sorry that's blue, but
Yeah.
this 3 goes into 9 3 times, but where's the 3? I can just call that 3, can I?
1/3.
Where'd the 1 come from? How many times does 3 go into 3? 1 time.
Oh, okay, got it.
Okay. All right, so I need to hurry up with this so I can answer Dakota's excellent question. So let me just go. All right, so are y'all okay now? Sometimes you'll cancel something out and there'll be something completely different left on the top. Whatever happens, happens. Okay? Now I'm ready to graph. I have a vertical asymptote at x equals 4. That means there's something on either side of 4. I do have a horizontal asymptote. I haven't addressed that yet. What's the horizontal asymptote? 0. Y equals 0. If you check for cross with this, it won't cross. You'll get nonsense. You'll get 1 equals 0. So it won't cross. My horizontal asymptote is y equals 0. And now I'm going to fill in some points. Before I do that, I want to make sure I don't forget to show the whole. Is it -1, -1/5? If you fill in 0, you get -1/4. If I remember right, the graph looks like this. And then there's a piece over here on the other side of 4, like 5. 5 gives you 1, and it's over here. And so it has 2 pieces. One of the pieces has a hole in it that you must show me. Will your calculator show you the hole? No. You've got to know it's there. And I'm sorry, that should be like, do y'all see what I've done? I'm trying to make it like connected, but there's a hole in it.
Oh, is the whole a circle?
Open circle.
Oh, got it.
It's an actual hole. It's way bigger on your graph than it is in real life, but if you drew it like it was in real life, would I be able to see it?
No.
I mean, I think Alina could actually see mine the other day because I did it with a pencil. But if I did it with a push pin and went shoot and then pulled it out, there'd be a hole in my shirt for sure because you saw me poke it in there, but I don't think we could find it. Okay?
How would you
draw that though, because it's really hard to get it close to one fit.
Not on this board, it is really hard. On your paper, just draw it somewhere between 0 and 1, but closer to 0.
I just chose not to show you the whole thing.
Oh, it's not going to, Anya, that's what I keep saying.
I thought
You
said
better
it was
know,
gonna
like, I
show
can
you.
make it show the whole, just because,
Yeah, I thought it was gonna be like that.
but I can make it do, you've seen me do that, I know how to make it do that, but it's not worth our time in here. If you do that on this problem, you're not gonna finish the test, you've gotta know it's there.
So
Table,
we find the hole and then, okay.
table agrees with you. There's all these buttons I can push, but there are a few holes, girls, listen. There's a few holes before that I can't even make my calculator show me, but I know there's a hole there. So don't get caught up in that, please, all right? Now, this is what I'm gonna give you to practice in addition to your worksheets that I've given you, and probably some work out of the book. Oh, let me tell you what's gonna be on the test. I'll list this on the class page. I hope a tour doesn't come out right now. Hi. I look really weird. So anyway, let me stand back up for a minute. I was about to pull up to what to do. There'll be a little bit of, and I'll be really clear on what you should study, but that sheet where you found increasing, decreasing, F of 1, F of, that stuff, max, min, a little bit of that, but not anything that's not on that worksheet. There'll be a couple of things like, and I'll make sure you know what to study, the delta mass where you would find on piecewise functions like F of 1, and I'll make sure you know, so you may want to study ahead of time in case you have any questions, and then graphing rational functions, okay? So I'll list all of that for you. You can, you're right, taking notes right now, but you can also check the list.
And the graphing rational functions is gonna resemble like this worksheet?
Yeah, yes,
So nothing
yes.
we haven't like seen before?
No, I'll keep that in mind when I make out the test.
And are we gonna have crossing the asymptotes?
I would check for that. I think that's pretty easy.
Okay.
So, yeah, I mean, I'm not gonna necessarily know if you check or not. When you get your test, it'll look a lot, that part will look a lot like this, where I have suggestions for you to do, but I'll actually be just grading your graph. So those are the side are like notes to self, okay? All right, so let me show you this real quickly. I'm glad you asked me that because I'm not sure I would remember to show you.
Well, technically if you're.
All right, hang on, I'm sorry. I got to do this before 1:35. All right, so this is plot all of the existing 5 features of the following rational function. Some may not be needed, just like if you get a fraction or a decimal, plot as close as possible, like Dakota was asking me. All right, this one I'm going to do in my head right now in the interest of time. Darn. Okay, I've got a minute. Let me see if I can go to the next problem. Just, that one's not hard, I just couldn't do it in my head. All right, this one looks like it's undefined at -5, but it actually makes a hole in the graph. So there's a hole in the graph at -5. I can't do this one in my head either. I would have to write it down on paper. All right, this one I could do in my head. All right, there's a vertical asymptote at -5. Watch how you can practice this. Hey girls, watch. Do you see it just gave me a vertical asymptote? And you can drag it wherever you want to. I'm going to drag it back here at -5. All right, it has a horizontal asymptote at 2/5. Do y'all see the 2 and the 5?
Yeah.
Has a horizontal asymptote, so get it as close as you can at 2/5. X-intercept at, I'm doing it really quick, x-intercept is at 4.5. Do you see how it gave me an x-intercept to move around? Y-intercept, oh, I'm sorry, that's not my x-intercept. Yeah, my y-intercept is -9/25. You know how to do all of this. -9/25. I'm not even sure where that is. All right, and then I think I've got everything in place. Plot rational function. And then it drew it for me, and I decided if I want to submit my answer, and we got it right. But you see, you can like totally interact with it, and then of course if you miss it, that way you almost like having me sitting next to you. So I will post that. I'll be super clear on what to study on Delta Math.
And where it says watch help video, is there a video like